trigonometric ratio or the SOHCAHTOA and Pythagorean theorem can only be used when we have right angle triangles. And to solve any oblique triangles, I need other laws to solve them. Yesterday we learned one of the laws, which was sine law. And then sine law can be used when you have what? What kind of triangle? What information in a triangle do you need to have? Two angle on one side. And what's the other situation?
Two sides and one opposite angle.
That's right, and two sides and an opposite angle. Okay? So if you remember, for sine law to be used in a triangle, not a shape. You need to be given a triangle, right, with any two angle and a side, okay? Or you need to be given two sides and an opposite angle. So I have to have an opposite angle to one of the sides, okay? Then I can use sine law. Now, what if I don't have these two cases? What if I have, for example, this case, where I'm given this side, I'm giving this angle, and I'm giving the other side. So in this case, I have two sides, but I don't have an opposite angle, right? I have what we call the contained angle, right? In this case, I can't use a sine law, okay? Or if I have another case where I have all three sides given to me, right? I can't use the sine law because I don't have any angles in here, okay? So in these two cases, we're going to have to use the cosine law. So the cosine law states, in any oblique triangle, if you're trying to find a side, so if I'm trying to find, in this case, I'll be finding this side, right here, which is the opposite side to the contained angle, then it's a squared equal b squared plus c squared minus 2bc cos a. Okay? It's called the cosine law because it has that cos in it, cosine of the angle. Okay? So, look at this. If I have a triangle, I have angle A, B, C. I know side B, and I know side C. Okay? And angle A, because that's a contained angle. Okay? In this case, I'll be looking for side A. Okay? So I'll be looking for this side right here. If I'm looking for side A, it's a squared equal to b squared plus c squared, because I know the b and the c, right? Minus 2bc cosine angle A. So the b, the c again, and the angle A are already given to me. Okay? Now, what if I'm looking for side B? What should I know if I'm looking for side B? What should I know if I'm looking for side B? Sorry, I did not hear what you guys said.
You should know A.
Side A and C, that's correct. And what else? Angle B. So if I'm looking for side B, I'm looking for that one. I should know side C, I should know side A, and angle B. Okay? And the formula becomes what? B squared equal A squared plus C squared, yeah? Minus 2AC cosine B. Okay? So no matter what the letters are, you should be able to create your equation. If your letters are X, Y, and Z, and you know X and Y and angle Z, you should be able to create the equation. Okay? What if I'm looking for side C? What should I know?
C squared.
So C squared equals A squared plus B squared 2AB cosine C. Now remember, these three formulas will be given to you on the formula sheet, but you need to, as I said, the equation is LMN, or if it's like the triangle is XYZ, you need to be able to change your letters. Now, that is if I'm looking for a side, and if I know two sides and the contained angle. Okay? If I know two sides and the contained angle, then I can use this formula or this equation, and I can solve for the side. Remember to take the square root to get the length of the side, right? Because this formula says a squared is equal to, or b squared is equal to. So at the end, you're going to have to take the square root to find the actual length of the side. Are we okay with that? Now, cosine law also be used. There is a mistake in this one, by the way. This should say 2bc. Okay? We'll fix that later, but this case, if I have three sides, so if I know side A, side B, and side C, if I'm given all of these three, okay, I can use all my sides to solve for my angle, okay? So if I'm looking for angle A, the formula becomes cosine A is equal to b squared plus c squared minus a squared over 2bc. This is an isolation of cos A from this formula. Okay? So basically what they did is they moved the b squared over, the c squared over, and divided by negative 2bc. Okay? But we'll give you the formulas. We're not going to ask you to isolate. It's already given to you. Okay? You just have to know how to, use it. Now, here's a trick that you need to learn is whatever you're subtracting matches the letter that you're subtracting has to match the letter of your angle that you're looking for. Okay? So if I'm looking for angle B, what would my formula be?
Cos B
Yeah?
equals a squared plus c squared minus b squared
Yeah?
over 2ac.
Perfect. Okay? So I'm subtracting the B squared. Are we okay with that? And then, again, it's good that you know how to find these formulas because if we have different letters. Now, this is cosine C, which is, yeah, perfect. Now, in this case, I'm going to get cosine, right? So what do I need to do to find the angle?
Invert.
Invert. So remember to take the inverse to get the degree of the angle. Okay? So cosine law can be used when you know two sides and the contained angle. Or if you know all three sides.
Got to teach her 2P instead of the MEL. She wants to have 3C when
Okay.
she goes to college.
Okay, when she comes in.
Yes, I'm sorry, here. I mean, these days in the course, just flip to
Okay.
2P.
Thanks. Are we okay with this? All right. So, what do I know here?
Two sides.
Three sides. So I can use cosine law because I know three sides. I'm looking for angle C specifically, right? So that means I have to solve for cosine C. Now what do we call this side?
D.
That's side D. What's this side? B. So what would my formula be? And this is side C. Cosine C equal to, yeah? B squared plus
D squared
D squared
minus c squared over 2bb.
D. Perfect. So B squared is 650 minus 500 squared. Don't forget the square. Plus minus 750 squared. over 2 times 500 times 650. It doesn't matter the order. If 650 first or 500, it's going to give you the same thing. Now, when you're inputting this into the calculator, 2 options. Actually, 3 options. It depends on your calculator and what kind of calculator you have. You might be able to enter it all exactly the same way as you see it. Okay, if you have that fraction button, okay, you can do that. It will be easy. But if you have a little bit of a backward calculator, you probably want to find the top first and then write it down. Find the bottom, write it down, then do your division. Okay? So, can you guys find the top for me? So 650 squared plus 500 squared minus 750 squared.
Minus.
110,000. And then find the denominator. Is it 6,500? 6500?
Yeah.
600.
0, 2 more 0.
6, sorry, repeat that, 6, 5.
I got
How many zeros?
4.
Yep. Because you're doing 2, 500.
I'm so tired.
Okay, now, if you're going to do to find the angle, what do you need to do? So you can divide these two, but to find the angle, what do you need to do?
Inverse.
Cosine. So again, if you're going to enter this in the calculator as is, not as a decimal, make sure you put a bracket. And then you can enter it as such. Make sure that you enter it with brackets.
80.
80 degrees. Now remember that always your greatest angle is going to be across from your greatest side. Okay? So basically, if I look at this triangle, I know that angle C should be the biggest angle. Okay? Because it's across from the biggest side. Right? So always, that's a good way to check your answer. Okay. So
It's not
an air traffic controller at T is tracking 2 planes. Application questions at its finest. An air traffic controller at T is tracking 2 planes, U and V, flying at the same altitude. How far apart are the planes? So you see that the first airplane U is at a bearing of 23 degrees, and airplane V is at a bearing of 75. Bearing means it's measured from the north axis clockwise. Okay? So yes, it doesn't say that in the question, but it's good to know these terminology.
bearings being measured from.
So when they say like at a bearing of 23 degrees, for example, okay, bearing of 23 degrees, right? So that means this is your north line. So from the north, you're going to measure 23 degrees clockwise.
Keys. Yeah. Okay, thank you.
Okay, so a bearing measurement is measured from the north line clockwise to your terminal arc. Okay, so if I'm measuring, for example, a bearing of, if I'm measuring, let's say, a bearing of 100 degrees, okay, eyes on me for a second. a bearing of 100 degrees, this is my north. If this is my north, that's 0, okay? Then this is 90, and this is 180, okay? 100 degrees, where would that be? In what quadrant then? It's going to be down because it's going to pass the 90, right? A bearing of 100, that means my line is going to be here, and then 100 degrees is this measurement. Okay? Sorry that this is not so aligned properly. I don't know why this is doing this. So, bearing measurement is measured from the north clockwise. Okay, so the first airplane U is 23 degrees, a bearing of 23 degrees, and then airplane V has a bearing of 75. We know that the distance from the traffic controller to the first airplane is 10.7 mile, and the distance from the traffic controller to airplane V is 15.3 miles. How can I solve this problem? I'm looking for how far apart are the two airplanes. So I'm looking at the measurement of UV. Yes?
Would you do 15.3 squared plus 10.7 squared minus 2 bracket
Okay, you know what?
15.3 close bracket open bracket 10.7 close bracket cosine the degree of 75?
So you are right. We're using that formula, and you are correct. We're going to have to use these two sides. The only thing that I don't agree with, does anyone know what would be the only thing that we have to change? So he said that we're going to have to use these two sides and then angle 75.
No, I think that's like 75.
Not like here, right? Like on the,
Oh, okay. Whoopsie.
they're not underneath.
No, I want you to.
Can you guys look at your
I'm
desk?
seeing if I accidentally put them away. I don't think I did.
Yeah.
Is it on like a thing like this?
Yeah.
Right. Can you guys check your desks, please?
Just have them. No, they would be visible.
No, he got the blue key.
Okay,
Got
no
the-
worries. Okay, thank you.
I'll come and help you.
Bye.
All right. So why can't we use the 75 degrees? Hayden? Because that's a whole angle. I'm only looking for the angle between the two blue lines. Okay? So basically I'm looking for this angle right here. Okay? That's right, because this is 23 right here, and the whole thing is 75. To find what this angle is, I'm going to have to do 75 minus 23. Okay? Then I have my contained angle that I can use this in. Okay? I'm going to leave you guys to check to do this one, and I'll come and take it. I'll come and I'll take it out.